Hello, everybody. I'm Vincent Lorenzo. I work at the CEA, a French National Research Institute, where we developed Papyrus with my colleagues here, Patrick Tessier and Quentin Menez, and others that are not here today. I will present you a brief Papyrus history, then the migration of components that we use in Papyrus. I will explain why and which new tools we will use. Then I will show you the result, and I will present you the future roadmap. So, in 2000, the CEA becomes a member of the OMG, an organism in charge of standardization. This organization standardizes many languages like UML, SysML, and others. In 2006, the CEA initialized the creation of Papyrus, initially in order to get a profile diagram for the UML language. Afterwards, we extend this tool to support all diagrams provided by UML. In 2008, Papyrus became an open source project under the Eclipse license. Since 2008, we developed many profiles like SysML, Marty, and some others, and many relatives. At CEA, we count 42 projects near our own Papyrus. So a very brief Papyrus presentation. So Papyrus is integrated as an Eclipse editor. On the left part, you have the model explorer that shows all elements of your UML model. In the center array, you have the Papyrus editor itself, here based on the GMF. And the left on this editor, you have the palette with the tool to use to create nodes and edge representing UML element for your model. And at the bottom of the area, you have the property view to edit this element, to edit reference, label, and so on. The three parts are highly customizable in Papyrus. In the Model Explorer, you can change the label, the icon, the children, and so on. In the central area, in the editor, you can change the shape of the element, the label, add or remove compartment, and you can change the tools available in the palette for your final user. At least in the property area, you can add new tab to show only main properties for your final user. In addition of the three parts shown on the screen, it also exists tabular editor that you can customize. You can also connect Xtext editor to edit properties, and you can add your menu using a well-known Eclipse mechanism. So in this presentation, I will show you a replacement of GMF part and property view part. So the migration. So as I said, Papyrus is 15 years old now, and it's still using the same technology at the beginning. This technology and some of these technologies are no more maintained, mainly GMF tooling. Papyrus is using a fork since 2021, and XWT that is not maintained anymore. The CEA take in charge its build and release since 3 years. So the goal of your update is to ease the maintenance and use up-to-date technologies. We want to also ease the creation of new diagram and creation of property view for the final customization. the benefits of this migration will be an homogenization of the look and feel between the views, between the several diagrams. We use this work to overhaul the specification of Papyrus itself, and we will prepare a migration for a future Papyrus web using shared technologies like EEF and Sirius web, with a common code for it to edit the UML properties. This last bullet comes after the start of the initialization of the migration. Okay. So we do this migration in two steps. We start a first step with working with Artal, a French company, about an improvement of the diagram code base, of the historic Papyrus diagram code base using GMF tooling. So in Papyrus, we extended GMF tooling many years ago, and we extend the extend template that generates your diagram. So the first point was to assume a fork of GMF tooling, merging your overriding template and the historical GMF template. And we also improve the generation itself to remove useless overriding method in the Java generated classes. So with this first work, we remove something like 816,000 lines of code for Papyrus diagrams. We gain efficiency and maintainability of the existing diagram. After this first step, we start with Artal technology to develop three diagrams with this new technology. We want to develop class, state machine, and sequence diagram. So, after some research, it quickly appears that Sirius was a good solution, and we start to implement this diagram with this new solution. We met several challenges. Firstly, of them, embed Sirius as a nested editor of Papyrus. We met challenges with the open, close, save action mainly. We also need to manage the Sirius session that is in charge of the editing domain of the undo-redo action. We have changes with the Sirius toolbar that initially refused to provide all its components in the Papyrus integration. And we have another changes, last one. In Papyrus, we used GMF element type to edit UML's elements. It is a required service for create, read, update, and delete element. In this first version, we don't success to connect the required service, so it was implemented from scratch directly in the diagram. Then we did a second step with OBO to focus on developing the other UML diagram, always with Sirius, of course, and developing a new property view with EEF, and exploring the connection of required services with Sirius diagram and properties. And around this point, at the CA, we start to think about to port a Papyrus as a web tool. So, to do the migration and be sure that we don't lose functionalities for your final user, we write specification. So we use, of course, the UML standard, a big book of more than 700 pages. But we use also the initial Papyrus implementation of the diagram. We develop as an internal tool to analyze all the behavior provided by the diagram, which node can be created in which other node, and which link can be created with which nodes or edges. So with this tool, we extract spreadsheet. We create spreadsheet like this for each diagram. So, for example, can we create a class inside a class? Yes, in the class diagram. And where can we create a dependencies? A dependency can be created between a class and a class and a component, and so on. So we have big spreadsheet of this behavior, and we use them to specify the new implementation of the Sirius diagram. With this new implementation, we also developed G-unit tests to ensure the good behavior of the new diagrams and avoid regressions. And we update user and developer documentation. So now we have Papyrus working with Sirius. And here it is the new version of our architecture. So to replace your GMF element type and edition service, we create a new project dedicated to the manipulation of UML element. We call it UML domain service and initialize it as a new Git repository inside the Papyrus project on Eclipse. GMF diagrams editor are now replaced by Sirius diagram editors, and XWT property views are now replaced by EMF property views. So now the behavior and the diagram changes. So new diagrams are integrated as nested editor into Papyrus, like the previous one. There is no change for the final user. The appearance of elements inside the diagram is preserved. All the capabilities have been preserved also. During this work, we also harmonize the usage of UML keyword. Keywords are some words in guillemets displayed inside the label of some element. And it was not very, we don't have the same look and feel depending on the diagram. So now it's uniform, it's harmonized. We also harmonize the usage of icon in all diagrams, because before some diagrams use icons, some others don't use. And we harmonize some behavior, some specific behavior between diagrams, like typing a UML property by drag and drop type from the Model Explorer on it. And so the final result is easier to maintain for the Papyrus team. For example, the Papyrus UML diagram common contains 94,000 lines, and its equivalent on Sirius base is 10,000 lines. For the UML class diagram, historically we have 74,000 lines, and now we have 4,000 lines. So the code has reduced, so the maintenance will be easier for us. So, as I said previously, Papyrus is a highly customizable tool. So in the previous version, to customization for final user, we started by creating a UML profile for the use case. This step is the same with the new version of Papyrus. Then we create element type inherited from UML ones to imply new behaviors for UML elements and adapt them to the user use case. Now we will create a new domain service for CRUD. For the diagram part, we inherited from existing diagram to reuse figures, behavior, and customize the palette. using Papyrus Sirius, we will create easily new diagram. There won't be inheritance between them. And for the property view, with the old specialization mechanism, we create new property view with XWT. Here, we will create new property views with EEF. So how to create a new diagram? So in the left part, you have the UML class diagram based on GMF gen, the old mechanism. And at the top of the left part, basic GMF gen, it was the official GMF gen model. And you can see the bottom part, Papyrus extension, was your initial extension of GMF before the first step of refactoring. On the left part, you have a O-design file from Sirius showing the creation of a UML class diagram. For property views, on the left, you have the old version of Papyrus defining tab, views, and at the end, element and properties of the property views. And on the right, you have the new version based on Sirius EEF property views. So now I will show you some demo. So here, firstly, illustration of the UML properties O-design file to use to customize EEF properties. So it is the Sirius file with the Sirius customization mechanism. And here, a property view used to edit the properties of the UML page. And the group UML with the property, we will show name, label, qualified name, is abstract property, and so on. Here, the O-design file used to define the UML class diagram with Sirius. So I will show you the class node with its compartment and the objects that can reference the attribute compartment in the import tab. So attribute compartment can contain properties label nodes. Okay, that's all for the first demo. Second one, the illustration of the diagram with Papyrus Sirius. So here, you have a Papyrus class diagram with the old class diagram implementation. And you have, at the bottom, the old XWT property views. So here, the rendering, the XWT rendering used to edit a family and the name of a family. So now we will create a class diagram Sirius-based. So we can drop the nodes. So now we have the full nodes. The small icons on the left of the diagram in Sirius indicate if the diagram is synchronized or not. When it is orange, the diagram is not synchronized. So to show some element of your model displayed in the Model Explorer, you need to take them and to drag and drop them into the diagram in order they appear. So that we did with this 4 node. Now we will synchronize the diagrams. Now the icon is yellow, small refresh, and the edge between the nodes automatically appears. On this version, the drag and drop of the edge is not yet implemented. It will be the case in the future release. Okay, so now we will show the switch between the XWT properties views and the new EEF property views. So there is a preference space to choose. So we were in XWT, and now we will be in EEF. So we select the properties. We need to close the property view, and we reopen it. Now it is EEF property view. The look and feel change a little bit, and you have now the documentation of each field with the question mark, the icon. That's all for the demo. Now we finish with the roadmap. So we plan to release a Papyrus Sirius-based version, an alpha version, at the end of 2023. This new version will provide you new property views with EEF and new diagram based on Sirius diagram through an update site that you will be installed on your standard Papyrus version. In June of next year, we'll plan a beta version of Papyrus Sirius-based, and in the third quarter of 2024, we plan to provide a diagram migration tool from old GMF diagram version to new Sirius diagram version. We plan to stop the new development on the Papyrus EV client at the beginning of 2025. I thank you for your attention. Do you have questions? No question? Thank you very much.